Sample problem 8.10. High oil and gasoline prices have renewed interest in alternative methods of producing energy, including the clean burning of coal. Part of what makes dirty coal dirty is its high sulfur content. Burning dirty coal, quote dirty coal, produces sulfur dioxide, SO2, among other pollutants. Sulfur dioxide is oxidized in the atmosphere to form sulfur trioxide, which subsequently combines with water to produce sulfuric acid, a major component of acid rain. Draw all possible resonance structures of sulfur trioxide. So we're just going to do sulfur trioxide, not dioxide, so SO3. So let's begin by doing the skeletal arrangement. When we do Lewis structures and we're doing resonance investigations, the arrangement of the atoms, which are represented by the symbols, those will always be the same. So we're not going to move the symbols around. We're just going to move lone pairs and bonds around. So let's count up valence electrons. Oxygen is in group 6A, but so is sulfur. They're both in 6A. So there's 1 sulfur and 3 oxygens. Each has 6, so that's 6 times 4. That's 24 electrons. We've already used 6. Okay, 18 electrons. Now what I'm going to do is I'm going to write the same skeleton over here, and then we'll see if we can take different paths. Okay, so let's do the one on the left first. 18 electrons to distribute. Generally, we recommend that you get the surrounding atoms up to 8 first, and then push pairs of electrons onto the central atom to get it up to 8. Okay, so I just put 18, right? 6, 6, 6, that adds up to 18. Now, the issue here is that the sulfur only has 6. So if I take a pair of electrons and push it over here from one of the oxygens, we now have a double bond and 2 lone pairs on that oxygen. Now, if you want to practice formal charges even further, okay, what I'll point out is that in this particular Lewis structure that I just drew, the sulfur has a formal charge of +2. This oxygen has a formal charge of -1. This oxygen has a formal charge of -1. And this oxygen has a formal charge of 0. So you can practice those as well. So there's one possibility. But there's another possibility. Again, suppose that I take these 18 additional electrons, the ones that we need to account for, and instead of pushing this pair here, I'm going to push this pair here from another oxygen atom, and that's the key. What we get now is a double bond to the right. Okay? And a single bond to the left. Okay? So now what happens is the formal charge is -1 here, 0 here, 0 here. I'm sorry, -1 here. And +2 here. Okay? And then I can do one more. Now I'm running out of room here. Could have done it over here on the left. It's a little tight there. So what I'm going to do is I'm going to start over here. And again, we're going to put in 18 electrons. So I'm going to fill out. It's a really good method for doing Lewis structures. You fill out, you use all the remaining electrons so that the surrounding are all up to 8. Each oxygen has 8. That will very often leave the central atom with a deficient number, not quite 8. But now, instead of pushing this pair here or pushing this pair here, we could push a pair from this oxygen and get the double bond over here. What this tells us Let me finish this Lewis structure and we'll do an evaluation. We'll sum it up here. The formal charges now are 0 for this oxygen, -1 for this one, -1 for this one, and +2 for this one. What this tells us is that we actually have 3 really equivalent, right? We cannot say any of these 3 is better than the other 2. They're all equally fine. If you look at what the formal charges are, they all have the same combination of formal charges. It's just where those formal charges are. Okay? So these are all equivalent. So what we would say is that, in fact, nature, in its sophistication, is not have any single or double bonds in this arrangement. The SO3 molecule has about 1 1/3 bonds. Now, a fractional bond might seem really weird to you, but remember, electrons are waves and they can do very interesting things, right? So there's 1 1/3 bonds to this oxygen here, and then 1 1/3 bonds here. If you add 1 1/3, and there's 3 of them, okay, you get 4 bonds. Okay? And so 4 bonds, well, each of the Lewis structure has 4 bonds, 1, 2, 3, 4. So what I'm doing is I'm representing it each as 1 1/3. Okay? So it's a resonance, meaning that the actual structure is an average of these 3. It's not that it's this one or this one or this one. It's an average of all 3 structures. So we could, it appears, draw 3 Lewis structures, 3 possible structures there.